Okay, welcome to the second part of the second lab, Ansys Mechanical Basics. We're going to be using the stress wizard in this second lab to set up and solve a structural model for stress, deflection, and safety factor. What the model consists of is SolidWorks and step files representing a cover, and this cover is intended to be used in an external pressure application where we apply 1 megapascal. It's made out of aluminum alloy, and what we want to do is verify that the part will actually function in its intended environment and have a sufficient safety factor. So in this lab, what you'll learn is how to load a SolidWorks model into Ansys, select materials for your simulation, and apply loads and supports to the model, and then review the results. Alright, so now we're going to discuss the assumptions that we're taking in this simulation. What we're going to do is represent the constraints on the counterbore's bottom contact area and inner sides using frictionless supports. This is where the cover will be in contact with the screws that are holding it down, as well as the other part that it's attached to. We're using frictionless supports because they place a normal constraint on the entire surface. So what we're doing is allowing translational displacement. Basically, we're allowing it to move in all directions except in and out of the supported plane. Alright, so this allows it to move, however it does not allow it to move into or out of the thing that it is attached to. Since we expect frictional forces to act in these areas, this is a very conservative approach, which is a good approach. The environment that the model is going to be in consists of a 1 megapascal pressure applied to the 17 exterior faces of the cover. So you can imagine that there's some sort of fluid, liquid, gas, etc. that's pressing against this cover, trying to collapse it. And this is at a pressure of 1 megapascal. So in the first portion, what I'm going to show you is how to load the actual SolidWorks model into here. This is more of a real-world approach, since typically you'll be doing your senior designs in SolidWorks and importing them into Ansys rather than being given a model. There are two ways to do this, and I'm going to cover both approaches. The first approach is directly from within SolidWorks itself. Now this is assuming that your computer, which may be your laptop or a lab computer, has the Ansys SolidWorks plugin installed. In order to do that, you see here my folder with Lab 2 Problem 2, and I have my cap fillets file. This is my SolidWorks file. I will open it in SolidWorks. And inside of SolidWorks, you may be asked by FeatureWorks to do feature recognition. You may answer no here, but that depends on what you're doing in your actual problem. And then we simply go up into Tools, and then this is where we will see our Ansys plugins. So if I were to use Ansys version 16.2, I would simply click Ansys Workbench right here, and this would launch Ansys Workbench and import my geometry. Now the second approach is a little different. This is assuming that you do not have the Ansys plugin installed in SolidWorks. So in this case, what I'm going to do is go to my Ansys version, and I will launch SCDM, which is the modeling software built into Ansys. It is the SolidWorks-like software built into Ansys. And once that is open, I'll go to File, Open, and I'll go to the folder that contains my file. However, you'll notice that it's currently set to filter space claim files. Change this to all files, and then you can select the SolidWorks file here and open it. At this point, it will load your SolidWorks file. Then to bring this model into Ansys, what you'll do is actually move over to Workbench here in the ribbon, and then click on Ansys Workbench. At this point, you should have a geometry cell inside of your project schematic. Now if you loaded from SolidWorks using the SolidWorks plugin, you'll see that this geometry section right here will have a SolidWorks logo. If you took the second approach and loaded from SCDM, you will see this logo that I have here inside of your geometry module. So the next step will be to actually set up the static structural simulation that we plan on performing. So we'll go to the toolbox and we will drag static structural into a standalone system here. So you'll see these green and red blocks appear. Drop it into the standalone system, and now you have your standalone system. So to do that, we will click and drag the geometry from the cell A to cell B3, and you see here that it shows share A2. When we let go, it'll create a link. So now this geometry is being imported into cell B3, and the check mark will appear. Now it shows that our model will need to be updated. So this will be our next step. We'll double click on model, and this will load Ansys Mechanical. Once Ansys Mechanical is loaded, you'll see this cover appear once again inside of your window. The first step, and I will remind you this very many times, is go to Units and check and verify that you're in the correct unit system. For my simulation, I want to use millimeters, kilograms, newtons, seconds. So I'll click this and verify my units. Our next step will be to load the Ansys Mechanical Application Wizard. In order to do this, you'll go up to the ribbon and you'll see this green check mark. When you click on it, you'll see this Mechanical Application Wizard show up, and it'll tell you the required steps to complete this simulation, step by step. So this is a very useful tool to speed up your process and make sure that you don't forget anything. The first step is to verify the material. So we will click on Verify the Material. Here you'll see that the material is currently assigned to structural steel. The tooltip will actually tell us to go under Engineering Data and Workbench to assign the material properties. So in order to do this, we have to take a step back and minimize, because if you remember from the problem statement, this cover is supposed to be made out of aluminum. So we'll go to Engineering Data here and double click. And once we're inside of this, we'll go to our Engineering Data Sources at the top ribbon and click on it. And then you start to see your engineering data sources for materials appear. So I'll slide this over so I can read it more easily. I want to find aluminum, so I know that aluminum exists under general materials. And then if I just scroll up here, I see aluminum alloy. So I will click on it and then click this plus immediately to the right of it that says Add to B2 Engineering Data. And then we click on it. Once this is complete, we can go back to the tabs at the very top of the screen and click on Project. This will bring us back to our project. Once we return to our project, you'll notice that the model cell now needs to be updated. So what we do is click on Model, right click it, and then hit refresh. Now once you refresh it, you then see the lightning bolt appear. We can then go back to Ansys Mechanical and click on it and go back to our material and see that aluminum alloy is now available as a material. So we'll click it and change the material to aluminum alloy. So we'll go to the required steps now. We've already verified the material. Then the next step asks us to consider multi-step analysis. For this simulation, we don't need multi-step analysis because we're simply applying the load after one step, so we can skip this point. The next step will be to insert structural loads. You see that a call-out appears here that this analysis requires at least one structural load. If you remember the problem specification, we want to apply an external load of 1 megapascal to the outside of the cover. So what we'll do is click on Loads and select Pressure. When we do this, we see that pressure appears under our static structural simulation. The first thing that we have to do is select the geometry to apply it to. So we want to select all of the exterior faces of this cover. So first I'll make sure that up here I'm in face selection mode, and I am. So I will click the exterior of the cover. So in order to save time, instead of clicking on each one of these faces individually, I'll go back up to the ribbon and go to the Extend Selection tool, and I'll go in there and click Extend to Limits. So what this did is just selected all of the faces next to my original selection. Then I can go back to geometry and hit apply. When I do this, you see that I've applied the pressure to all 17 of these faces that are now marked in red. My final step for applying this pressure is to specify the magnitude. So I will simply go here and click 1 and enter 1 megapascal. So this is the end of applying our loads. Once we're completed inserting our structural loads, we'll go to the next step in the mechanical application wizard. The next step is to insert the supports. So when you click on this, it'll tell you that this analysis requires at least one support or displacement load. So we'll click on our supports and select the frictionless support, because if you remember earlier from the problem specification, we decided that we would use a frictionless support to allow the body to slide without going into the normal plane. Once we've selected this, we then have to apply it to a geometry. So first, we have to select these interior faces where it would be fixed by some sort of screw or hex bolt. In this case, we'll control click on all of these interior faces. Once you've selected all of the counter bore faces, you can hit apply, and this step is done. But then, if you flip the model over, we have two additional faces here that we want to apply a frictionless support to. This is where it'll be in contact with the other body. So we'll go to static structural and introduce additional supports. We also want these to be frictionless supports. Let me note that you can also do it the way we did it the last lab and right click on static structural and go to insert frictionless support here. However, I find it easier to go through this ribbon. So we'll select frictionless support again, and then we'll click this face, which we will then once again extend to limits. So that will select all of the surrounding faces, and then control click on this final face. So now we have all faces surrounding selected. When you apply, you should see that there are 9 faces total. So all surrounding faces have been selected, and then this lip surface has also been selected. We now have all of our frictionless supports selected. So if you'd like to verify this, you can click on static structural again, and then you will see that your pressure A is on all of the red faces, and it's 1 megapascal. And your frictionless supports are all in blue. These are B and C on the outer portion, the lip, and then all of the counter bores. If you don't have this, you should go back and correct it before doing anything additional. After you verify that all of your boundary conditions are correct, that you have the correct pressure being applied and the correct frictionless supports, click on Solution. When you click on Solution, you'll see these various types of solutions appear. So for this problem, what we're going to want to see is a few things. The first thing will be our total deformation, so we'll click on Deformation followed by Total, and this will add total deformation to our solution. The next thing will be equivalent stress. So this is von Mises stress, which is a very common thing we look at in engineering because it's used to calculate safety factor. Add this to your solution. And then the final thing that I'm going to insert is my stress tool. So if you go to Tools, click on Stress Tool. You'll notice that inside of the stress tool, you have safety factor, which is ultimately what we care about from the initial problem statement. So once all of this is done, you have all of your solutions set up. The next step will be to create the mesh. So we will right click on the mesh and hit Generate Mesh. This will create the default mesh with no refinement. So if you take a quick look, you'll see that the mesh is rather coarse. For the purpose of this example, this is sufficient. Once the mesh is generated, the final step is simply to solve the problem. So you can go to the top ribbon here and click Solve, or similarly, you can just right click on Solution and hit Solve. Either way is acceptable. Since in the last lab I did it this way, in this lab I will click the Solve button from the top ribbon. So after a short period of time, you should see that everything has updated and has check marks next to it. This means that your solution is complete. The first thing we're going to do is take a look through our results. So you'll see your total deformation, which you can rotate around and compare this to the PDF in the lab to see that your maximum value is somewhere around 0.06. Our equivalent stress, which has a maximum value somewhere around 260. And finally our safety factor, which you'll see that our minimum safety factor is approximately 1.05, meaning that for the load applied of 1 megapascal, this barely scrapes by. So remember that if the safety factor is less than 1, the product will fail. If the safety factor is greater than 1, then the product should survive. However, typically in engineering, a safety factor of only 1.05 leaves little room for error, and we usually like to have this be a little bit higher. The final step that I'm going to show you is how to generate a report from all of this data. This is very useful for your senior design projects because it'll allow you to have a nice document that can show all of your results. So if you click on the final thing in Mechanical Application Wizard, you will see View Report. So once the report is generated, you'll see that you have a figure of your model, as well as all of the parameters from Ansys, along with all of your results in the report. So we can, for example, click on equivalent stress, and this will take us to the equivalent stress, where it tells us our minimum and maximum. You can also include figures here. Similarly, we can click on safety factor, and this will take us to the portion of the report where it tells us that our minimum safety factor is 1.0541. Another very useful tool at this point is the Print Preview tab. So if you were to take a screenshot of this screen in Ansys, it doesn't go very well in the report. However, if you click Print Preview from this screen, you'll see that Ansys will generate a nice figure for you for a report format where you don't have to screenshot. You can simply go up to the top left of the ribbon and you'll see Print Preview appear here. And you can select what kind of image resolution do you want, as well as whether you want to print it, but you can also send it to Microsoft Word for use in your lab report or senior design report. So this is a much easier way than attempting to screenshot and playing with some sort of image editing software. So now that we're done with the lab, you've calculated the total deformation, you have calculated the equivalent stress, you verified that the safety factor is above 1. It's time to actually go and do your homework for this lab and see if you can determine the maximum pressure, as well as look into some manufacturing considerations with different materials. Have fun.